Assalamualaikum warahmatullahi wabarakatuh. So, at this occasion, I like to talk about parabolic motions. So, yeah, as you can see right here, this is the pictures of a parabola. This is a picture of a parabola. So at these pictures, we can see there's an alpha right here. This is the alpha, or the angles of the parabola, and there's also a velocity. The initial velocity is 60 meters a second. Why the initial velocity is so big? Because this is a gunshot. So this is a parabola of a gunshot at the angles of 30 degrees. At these pictures, we're gonna solve problems about the y max and then the x max, and we're gonna find the height of the bullet when it's at the bullet has been launched for 2 seconds, and also we're gonna find the bullet when it reach 5 seconds. The height of the bullet when it's reach 5 seconds. So first, we're gonna know about the initial velocity of the y, or the initial velocity of the y. You can call it FOY. And also we're gonna know about the initial velocity for the x. For the initial velocity of the y, the equation will be the initial velocity times sin of 30, or alpha. So or alpha, and the alpha is 30, so it's going to be 60. Sin of 30 is going to be half, so the solution is 30. So the initial velocity is 30 meters seconds. How about the x? So the x is a little bit different. It's gonna be VO times cos of 30 degrees. So it's going to be 60 times the cos of 30 is going to be half times root of 3. So it will be 30 times root of 3. Next, we already know the initial velocity of the y and the x. We're gonna find the y max. So for the y max, there's an equation for that. The equation is going to be VOY, that we already found it before, divided by 2g. G is the gravitational acceleration, and it will be 10. We're gonna use the g is 10. So VOY, which we all know is 30 squared, divided by 2g. Gonna use 10 at these problems. So it's going to be 900 divided by 20. So its solution is going to be 45 meters. So the y max is 45 meters. What about the x max? The x max is different from the y max. So how could we find x max? Is going to be Vx times T max. What is Vx? Vx is the velocity of the x. But as we all know, velocity of the x, or the horizontal path, is going to be constant. So the Vx going to be the same as the Vox. So yeah, it's going to be 30 root of 3. And how about the Tmax? Tmax as 2 Voy divided by G. So it's going to be 30 the root of 3 times 2 times Voy, 30. We're gonna divide it by 10. Oops, the paper's already run out. So the results, it's going to be going to be 30 times 2 3 times 2 times 3, and it ended up with 180 root of 3 meters. This is the X max. Okay, the next question. How about if we want to calculate the height when it's at certain time? Yeah, like this question. We're gonna find the height and also the length of this bullet when it's at 2 seconds. So we're gonna label this as A. So AX, it's going to be Vox times the time. Yeah, the T times. So we all know that Vox is 30 root of 3, and the times of the bullets, it's going to be at 2 seconds. So we're going to put it 2 here, and the result is going to be 60 and the root of 3. What about the Y? The Y, it's going to be Voy times T minus a half times G times T squared. So it's gonna be, looks like this. We always 30 times time is 2 seconds, 2 minus a half of G is 10. The time is 2, and got squared is gonna be 4. We work out the equation. Sorry, I don't look up at the camera. So this is what I'm talking about before. We're gonna continue it. So let's end up with this. So the height of this bullet at this certain point, certain time, is going to be 40 meters, and the length is going to be 60 roots of 3. Yeah, as we can see here at this equation. Next, we're gonna find it when it's at 5 seconds. Same as before, but the time is changed. So we're gonna label this as B. So it's going to be Vx, it's going to be same as before, Vox times T. So it's same as before, so it's 30 root of 3 times 5. So it's going to be 150 times root of 3 meters. Yes, the equation is the same as before. So yeah, so it's going to be VOY times t minus half GT squared. VOY is 30 times time is going to be 5, half GT 10 t squared, 5 squared is going to be 25. It's 5. 30 times 5 is 150 minus 125, so it's 25 meters. So for B, the height is going to be 150 root 3, and for the length is going to be the height is 25 and the length is 150 times root of 3. So what about the velocity of this bullet when it's at 2 seconds? What is the velocity? How could we count it? So to find out the velocity of A is actually, wait a second, as VOY, because 2 as before the highest point, so the y is still going up, the equation is going to be minus, so it's going to be VOY minus G times T. So it's going to be 30 times minus G times T. The G is 10 and the T is 2 seconds. So it's going to be 30 minus 20. It's going to be 10 meter a second. So the velocity at this point is 10 meter a second. What about this? 5 seconds, because it's already past the Y max. It's already going down. It means it's the acceleration is going to be plus, but on the other side, this part is still going up, so it's against gravity. So that's why the equation is minus. It's different with the B because it's already past the highest point, so it's going down, so it's accelerating, so the G is plus, so it's going to be looks like this, the VOY same as the before, but this one is plus because it's going down, it's going towards the earth, it's accelerating, the acceleration is plus, so plus GT, so the VOY is 30 plus the G is 10 times the time is 5, so the velocity for the B when the bullet is at B is 80 meter a second. So the bullet at this point is going to be 80 meter a second. So yeah, that's all for the parabolic motion. And we're gonna have a circle that have a radius of 2 meters. At the tip of the ropes, there's gonna be a rock that's have a weight or mass of that have a mass of 1 kilogram. This circular motion, its spin 600 times at a minute. So it spins really fast. It spins 600 times at a minute. At this problem, we can find so many solutions. We can solve many problems. There's several problems that we will talk here, such as the frequency of this motion, these problems, and its period. Also, we're gonna find its omega, or you can call it as angular velocity, and then you're gonna find the velocity of this problem, this velocity, and next we're gonna find the centripetal acceleration, and at last we're gonna find the centripetal force. So first, what is the frequency of this motion that have 600 that spin 600 times a minute? So the equation for the frequency is going to be n, the times of the spins, divided by time. The n is how many times it spins, and the t is how long it's been spinning. So it's 600 divided by 60, because a minute is 60 seconds. We need to use the t is as a second, because the universal what is it called? Forgot. Yeah, just that. We need to use it as in a second, not in a minute. So it's gonna spin 10 times a second. So a frequency is how many spin does it, how many time it spins in a second. What about period? Period is how long it needs to spin in a second. In one spin, how many times that is required. So it's gonna t divided by n. So it's 60 divided by 600. So it's gonna be 1 to the 10, 1 over 10, or we can call it 0.1 0.1. The period is 0.1 second. So one spin, it's going to be needed. It's going to be only achieve. What is it called? Oh yeah, just like that. Just say that the period of this motion is 0.1 second. So move on to the next problems. We're gonna find its omega, or the angular velocity. So there's many ways to find omega. You can use 2 pi divided by period, or we can use 2 pi the times frequency. We can use one of this. The results gonna be the same. I'm gonna use this equation, 2 pi times frequency, or 2 pi, the frequency is 10, so it's going to be 20 pi rad a second. The omega is the unit is rad. Next question, we're gonna find the velocity. So the velocity as, how could we find velocity as omega times r? So as we all know that omega is 2 pi per t, or 2 pi times frequency, it's gonna times r. But in this case we already know what is omega is. It's 20 pi, right? So we don't need this equation anymore. We just need to plug the result that we already found before. So it's going to be 20 pi times the r. The r is 2 meters. So the velocity is 40 pi meter a second, because it's a velocity. Why do I stay with pi? Because pi is really hard to work with. It's gonna be really long. The decimals is so many, so I just keep it with pi to make it simple. It's gonna be looks really busy if I work out the pi, so gonna stay with this stuffs. So the velocity is gonna be 40 pi meter a second. Next problems is the centripetal acceleration, or we can call it as AS. This A is stand for acceleration, and the S is going to stands for centripetal. So it's going to work out as centripetal acceleration. So the equation is going to be omega squared times r. Centripetal acceleration, there's also many ways that we can work with, such as there is 2 pi per t squared, or we can use 2 pi frequency times frequency squared, or we can use the equation that we do before, this one, as v per radius, or v over radius squared. We can choose one of this, but in this case we already have what is omega as 20p, and we just work with that. So it's going to be 20 pi squared times r. So yeah, 20p squared. So it's going to be 400 pi squared times 2. So it's going to be 800 pi squared. So the acceleration is 800 pi squared meter a second squared, because it's an acceleration. So next is the centripetal force. How could we find the centripetal force? As F is stand for the force, is going to be mass times centripetal acceleration. As I told before, we can find acceleration like this, or this, or even this. It's up to you, but in this case we already know what is the amount, is the solution, so gonna just put this down. So the mass, as I told you before, 1 kilogram. We're gonna use the universal unit, is kilogram, is going to be 1, and the acceleration is going to be 800 pi squared. So the force, it's going to be 800 pi squared Newton. And yeah, that's for the centrifugal, the circular motion. I'm gonna write down the solution. F is gonna be 10 hertz, and the period is 0.1 second, and omega, the omega is going to be 20 pi rad second. Next is the velocity. Velocity is 40 pi meter a second, and centripetal acceleration is 800 pi squared time 800 pi squared. And the last one is F, the centripetal force. It's 800 pi squared Newton, and this one is meter square and meter over S. And that's all I can tell you. So yeah, thank you for listening. Assalamualaikum warahmatullahi wabarakatuh. Bye bye.